Hello all, welcome to my channel. So this is the second part of our power conversion series and this is the continuation of the previous video. So if you have not watched the last video, I recommend you please watch it and then jump to this video. Okay, so before moving ahead, just quick question for you guys. Question is like what would happen if we charge our battery directly with the AC power? Would our battery charge, or if it is charged, how should it be done? Okay, if it's not charged, what the adverse effect could be the uh, our battery? Okay, this is the first question. One more question is why battery cannot store the AC? If you know the answer, please comment your answer in comment section. Okay, so these both are the very important question that should to be come in mind when we are studying this conversion. Why we are doing this conversion? What is the requirement of this conversion? Why we are not storing the AC directly to the battery? So this is the uh, genuine question, right? That should to be come into our mind. So please comment your answer. Meanwhile, I am moving ahead. So in this journey, AC to DC conversion, today we will discuss so today so in this journey of AC to DC conversion, today we will discuss each component, especially the role, their responsibility and the functionality of these component during the conversion from AC to DC. So today we will try to cover zone 1 and zone 2. Okay, so as I told you, like I have break down all this process in 3 zone. So in zone 1 you can see is the AC to DC conversion, and zone 2 is the power processing, and zone 3 is the DC battery interface. So today we will try to cover first two zone, and in the upcoming video we will talk about the last one, the zone 3. Okay, so let's get started. So zone 1 you can see here is simply saying like AC to DC conversion. So okay, so now let's get started with zone 1. So for now I don't want to deep into the each individual component. Instead, let first understand the big picture. Imagine you have just plugged your vehicle into the charger. So the electrical power has arrived from the grid, right? But there one important thing that keep in mind and need to be understand. The electricity does not go directly to the battery, right? The AC power that is coming from the grid, our battery can't accept it. It's need the DC power only, right? So before it can reach the battery, it has to go through the several stages. It has to be passed to the several stages for the conversion from AC to DC. And today we will talk about this stage first. In our case, we are um, divided as a zone wise. So we will discuss it zone 1 today and zone 2 also. So think of zone 1 as a preparation zone, preparation state, okay, the beginning of stage, where the job here is to take the AC power coming from the grid, okay. If you can see in the slide, so the power which is the AC is coming from the grid, right? You can see in the picture in the presentation, and converted into the clean smooth DC power at the end that can be processed by the next stage. In our case, in next zone we will discuss in upcoming in upcoming videos. So we mainly have three important steps. If you can see in this slide carefully, the first is our AC grid, that is that the pure power is coming to us as the form of alternating current. The EMI filter, then bridge rectifier and DC link capacitor. So let's understand what each one does, what their importance and how they work. So first we have the EMI filter, you can see in the slide, right? So its job is to remove the unwanted electrical noise and interface from the incoming power. Then come the bridge rectifier. Don't worry, I am just giving you the overview. We will discuss detail going further, okay. So I am just giving you the overview right now. So this is the second is the bridge rectifier, okay. So here you can see the combination of diodes, okay. Then the bridge rectifier uses the diode to convert the AC waveform into the pulsating DC, right? But this DC is still not smooth enough. Our completing this stage till here, this DC is not that we can get it our work to charge the battery. Still is not still this is not smooth enough, okay. That's why we need one more step, that we call it DC link capacitor come into the picture, okay. Hello everyone and warm welcome to my channel. So this is the second part of our conversion series, and this is the continuation of the previous video. If you have not watched that one yet, please jump to it and watch the last video before coming to this video. So in this journey of the AC to TG conversion, today we will discuss each component, especially we will discuss the role of responsibility and the functionality of the each component during the AC to DC conversion process, and we will cover zone 1 and zone 2 in okay. So we will we will discuss all these component one by one. Let's get started. Okay, so I want to uh, remember only this three block, right? So at beginning, not need to remember all those 9 to 10 items at the same time. So just remember these three blocks. Let's talk about these three zone one by one. Okay, let's move to the our first zone slide, that is telling AC to DC. So here we are talking the taking the AC power from the grid and converting it into the DC bus. Okay. Now zone 2 is, that is telling power processing. So here we are controlling, switching and transforming the electrical power. Okay. And the last zone is DC to battery. So here we produce the final control DC power required by the EV battery itself. So if you remember only one thing from the today session, remember this three zone only. Okay. Now going ahead, so remember only these three steps: AC to DC, then power processing, and DC to battery. Perfect. Now let's open each zone one by one, and we start discussing about it. So here in first zone, as if you move to the last slide, zone 1 AC to DC. So let's enter this zone 1. So our job here is simple, right? Take AC from the grid and create a usable DC bus. But we don't do it in one step. There are four important stages that is involved in it. First is AC grid. Second item is EMI filter. Third is bridge rectifier. And fourth is DC bus itself. Okay. So let's follow the electricity through these four stages. So moving ahead, if you can see this slide, this is where I will explain the four component. Okay, so this is the zone 1 where all this element is involved from AC grid to DC bus conversion. So we start with the AC first, we control the noise, then we rectify the AC, and finally we smooth the resulting DC. So this is the full journey of zone 1. Okay, so let's start talk about one by one. Let's let's start with the AC grid. So we started with the AC grid. This is the electrical power supply by the charging source. At this point the power is still AC. Now moving to the EMI filter, the second step. So the first stage is the EMI filter. So EMI here I just want to tell you, the EMI here stand for electromagnetic interface. So its job is to control unwanted electrical noise and impurities. Okay, if I give you a simple example to understand this step, think of it like a filter in a water system. So before we use the water, we want we wanted to impurities can be removed before drink it, right? We need the clean water to drink. So similarly the EMI filter help here to deal with the unwanted electrical noise, to remove this unwanted noise and the impurities from the source that is coming from the grid. Okay, quick question for you. Can you tell me, has AC become DC yet after passing from the EMI filter? Not right, right? Correct. We are still dealing with the AC. Now third item here we can see the bridge rectifier. So now come the important conversion stage, the bridge rectifier. So bridge rectifier is a typically built using 4 diode. You can see here, this is the arrangement of 4 diode. I know most of you guys know about it in your college time. If you the electronics background, you probably study about this. Okay, don't worry if you forget about it. We will discuss it in detail in our upcoming sessions. Okay. Okay, what I'm saying, so okay, so this bridge rectifier is typically built using the 4 diodes. This is the arrangement of 4 diodes. So think of the diode like one way valve. If you don't do not recall the properties of a diode, let me remind you quickly. So diode is a kind of component. It is the electrical component that allow the current to flow in one direction only. It allows the current to flow primarily in one direction only. Okay, so this is the main properties of diode. By arranging 4 diode in a bridge configuration, we can convert the alternating input into the unidirectional and pulsating DC output. So in this video, my friend, I am explaining the conversion process. Okay, specifically the step involved in the converting AC to DC. We will understand the bridge rectifier in detail in next videos. Okay, I'm not going to deep dive on it. I will discuss it in a. I want to be discuss it in a separate video in detail, because it is the very important part for us. Okay, so we are not going to be deep diving to the 4 diode switching sequence today, as I told. We will cover positive and negative half cycle separately in the bridge rectifier session in the upcoming videos. Now, the fourth element is DC bus. Now we have the pulsating DC, but we need a much more stable DC bus for the next stage. This is the where DC link capacitor help smooth the voltage. Okay. Let me tell you a simple example. Think of a capacitor like a small water storage tank. It stores energy when voltage is higher and release the energy when voltage is falls. So that's why this help the reduce the ripples, the unwanted ripples that is coming from the bridge rectifier after last step. Okay, so the main working of this capacitor is to reduce the ripples. Now moving to the next slide. Okay, just give me a second. Okay, so let's talk about this slide. This is the zone 2. Zone 2 is related to the power processing. Okay. Okay, so now we have entered zone 2. This is where the really interesting power electronics work happen. So we call this power processing, right? If you go back, so till now we have discussed zone 1. Now we are entering in zone 2, the power processing. Okay. The DC power from zone 1 is now controlled and processed so that we can efficiently transfer energy to the battery side. So there are 3 major stages here. If you go to the next slide. First is PFC, then MOSFET and our IGBT switching, right? PFC, then MOSFET, IGBT switching, then high frequency transformer, sorry. So let's understand why we need each one. Let's discuss one by one all about this item. Let's start with the PFC. So here PFC stand for power factor correction. So the PFC stays control how the charger draw current from the grid. Basically it helps improve power quality and reduce the harmonics that is coming from the grid. So is PFC simply converting AC to DC? No, right? Its main purpose is to control the way power is drawn from the grid. Just keep in mind it's controlling the power that is coming from the grid. If I give a simple example to you to understand this PFC functionality, imagine a juice box and the straw. Let's give example of it. So your house electricity that is from grid, suppose like assume like it is the big juice box, the electricity that is coming to your wall socket from the grid, and assume the charger is the drinking juice through the straw, right? Now good drinking, what is the good drinking means? Like you sip the smoothly, like you, right, you drink the juice smoothly, like so as a, like that. I mean in the in continuous fashion, in a smooth way, right? Sometime you drinking the water in a smooth and very calm way, like that. The juice comes out evenly, there is no mess. Now bad drinking method, you do it like syrup and stop, then syrup and stop, then syrup and stop, like that. So in this case the juice box shakes, it's noisy, and it's not a nice way to drink. So moving ahead, what does PFC do? This power factor correction. So main job of PFC is like teach the charger to drink the electricity smoothly from the wall socket that is coming from the grid. Okay. So it teaching the charger, hey, drink the electricity in good manner, right? Smoothly. So instead of drinking electricity in sudden gulps, this is better for the power grid, the electrical wiring, and other equipment that is connected to the grid. So we can so when someone asks, is PFC simply converting AC to DC? Simple answer is no. The main job of PFC is to make the charger draw power smoothly and efficiently from the grid, right? So AC to DC conversion happen too, but that not the main purpose of PFC. I hope you understand the functionality of PFC. I tried to give you a better examples to make it easy. Okay. Now next step, moving ahead, MOSFET and IGBT switching functionality. Now comes on the most interesting part. We already converted the incoming power into the DC, correct? We done this part. So why we would be switching it again? The question come into the mind, right? If you know the answer, please comment. You can comment in the comment section. Meanwhile, I am moving ahead. So because we want to process the power efficiently at a high frequency. So power semiconductor switch such a MOSFET or IGBT repeatedly turn the electrical power on and off. So MOSFET and IGBT like a switch, right? So it's basically what do switching and the power on and off rapidly, the very quick, very fast, very quickly. And by doing this create a high frequency waveform. So question is, we already made DC, then why change it again? So I would like to give one example to understand this. So imagine you have a flashlight battery. So battery give you plain text like positive, uh, showing like positive lines, constant power it means, sorry. So that is the DC, right? That DC means constant power we are getting. Now I suppose I ask, like, can you use a transformer with this battery? Not really, right? Because if you don't know the functionality of the transformer and these properties, let me um, tell you quickly. So a transfer work only when electricity is changing. It does not work with the steady DC current. Okay. That's why we are doing this. Okay, moving ahead. What does a MOSFET do? A MOSFET is likely a super fast uh, finger, like pressing a switch very frequently, very fast, maybe 1000 times per second. It possibility, right? That fast it is. Let's use a way water example. Let's give me I would like to tell you one simple, make it simple. So let me give example. Imagine water flowing through a pipe like a DC power, smooth and continuous flow. And after MOSFET switching, the MOSFET keeps opening and closing the valve. Now water come in pulses. Electricity behaves similarly, right? The MOSFET chops smooth DC into the many teeny pulses. Why we need to create pulses? Because transformer love charging, changing electricity. The transformer love changing electricity, the chopped waveform, like that is that behavior is on off and on off like that. So create a changing magnetic field. That magnetic field allows the transformer to work. This question is why high frequency needed. Let me give you another example. Imagine two people carrying sand. Okay. So first method is suppose carrying one huge bucket every minute, and second person carrying a small bucket every second. Every minute huge package and a small bucket every second in method 2, and method 1 carry huge bucket every minute. Both move the same amount of sand, right? But the second method is easier to manage, right? Similarly, at low frequency need a large transformer, and at high frequency need a much smaller transformer compared to the previous one. That's why phone charger are small in size. Without high frequency switching, charger would be much bigger and heavier, right? So that is the main reason behind it. So what does the processing power efficiently means? One question come to the mind. The MOSFET mostly operate in only two states. First is on, it means switch closed, circuit full, completed, electricity can flow, right? Second stage is off, switch open, switch is open, electricity stops, circuit is incomplete. So because it spends very little time halfway between on and off, less energy get wasted as the heat. That is the main reason behind it. So what is the advantage of this? First is it will give you the better efficiency to you. It's smaller the charger, less heat produced, and smaller the transfer size. Okay. So till now summary is, imagine electricity is water. Assume like electricity is water. We first convert all power to a smooth waveform, a smooth water flow, that is DC. Then MOSFET is a very fast valve. Okay, it's open and close the thousand of time every second. This create water pulses, right? The pulses allow the transfer to work efficiently. Then high frequency pulses make the transformer much smaller and more efficient. Okay. All right. So we already converted the incoming power into DC. So why would we switch it again? The answer is because the transfer needs the changing electricity and switching the DC on and off very quickly. With the MOSFET or IGBT, we create a high frequency power that can be converted efficiently using the small transformer. That is the reason behind it only. Now moving to the high frequency transformer here. That's the high frequency waveform now goes into the transformer that is coming from MOSFET and IGBT, that goes to the high frequency transformer. And this transformer has measured two jobs. First job is the electrical isolation, and second job is voltage transformation. So it's allow us to change the voltage level accordingly to the requirement of the output side. So now the interesting question is why we use the high frequency transformer instead of simply using a large conventional transformer. Right, because operating at a high frequency allow the transfer too much smaller in size. That is our main intention, to make the transformer as much as smaller so that it can be portable easily. So for the smaller power transfer requirement, we need a smaller transformer. So in the upcoming video, we will start with zone 3. Okay. So till today, we have completed zone 1, zone 2, and we already discussed the component in detail, their working. So we will discuss the all component of zone 3 in upcoming videos in detail, and we will also complete the power conversion journey in the next video. Thank you for watching, and keep learning and keep growing. Bye bye.